Dobar dan, dobrodošli na još jedan webinar, ovaj put o dijelu Dassault portfolija, dijela Simulije, uglavnom o programu CST. Ja sam Matija Marković i predstavit ćemo vam zajedno kolega iz Italije Danilo di Febo, vrhunski Simulija konzultant koji zna doslovno apsolutno sve o CST-u, a i šire. Tako da bilo koja pitanja ako imate slobodno pitajte, upišite na chat dole što vas zanima i pokušat ću vam odgovoriti. Pa tako, eto, malo čisto o firmi u kojoj radim. Znači Computer Control, nekad smo bili HT Eurep, promijenili smo malo ime, ali čud ne. I dalje imamo poslovnice u Ljubljani i u Zagrebu, javite se u najbližu ili u najdražu, svejedno. I u principu imamo dosta široki portfolio kojima vam možemo ponuditi u ovom trenutku, znači od MCAD-a ili PLM softvera, znači kompletan Dassault sistem portfolio, njihov smo partner za Katiju, Simuliju, Delmiju, Enoviju, dijelove toga čuda. Tako da što god vas zanima slobodno pitajte i naravno već vama od uvijek poznat ICAD software Altium Designer. Pa što se skriva iza tih Katija, Simulija i tako dalje? Pa Katija je znači program s kojim možete modelirati i projektirati dijelove strojarstva ili nekakve mehanike. Vrlo zgodan i najčešće zastupljen u avio i autoindustriji. Simulija, znači to je cijeli dio kao jedan skup softvera s kojim možete simulirati kompletno sve što postoji na ovom svijetu, a često i šire. U ovom trenutku ćemo se bazirati na CST koji je zapravo samo za elektromagnetske pojave, a Simulija sadrži i još hrpu drugih programa, recimo tipa utjecaj kiše na gume, eksplozije u nekakvim utičnicama ili vatrozaštitnim uređajima. Možete apsolutno sve, zamor materijala, što god vam padne sigurno se može simulirati. Delmija, software za nadgledanje i projektiranje proizvodnje, kako napraviti proizvodnu liniju ili nekakve točnosti, preciznosti i tako dalje. Vrlo zgodno kad dođete do recimo nekakvo mas produkcije, što bi rekli. I je novija PLM software zapravo, kratko rečeno. Što vam mi možemo ponuditi, znači kompletnu prodaju, consulting, tehničku podršku, edukacije, radionice, metodologiju, znači bilo što vas zanima ili niste sigurni ili čak ste i sigurni, znate da radite dobro, možete nas slobodno kontaktirati, možda se da nešto napraviti čak i bolje ili možda mi nešto naučimo usput. Od inženjeringa tako, CAD konstrukcije, MCAD, ECAD, što god vam treba, simulacije, reverzibilni inženjering, NC programiranje, izrada postprocesora, PLM 3D experience, implementacija sustava, to je dosta kompleksno i tu nećete baš daleko bez stručnog vodstva doći, tako da slobodno se javite. Također ako treba povezati taj PLM sa ERP sustavima, imamo dosta iskustva s tim i razvijamo neke aplikacije koje mogu pomoći u nekakvim spajanjima, interfejsima između nekakvih različitih softvera. Pa čisto samo mali uvod u CST, o čem se radi. Kasnije će vam kolega Danilo di Febo prikazati kako se koristi CST na primjeru memorije DDR4. Vrlo zanimljivo i vrlo interesantno, vidjet ćete, i ta stvar radi jako, jako dobro. Sad, pošto CST Studio pokriva kompletni elektromagnetski spektar. I to je dosta teško zato što na nižim frekvencijama su jedne pojave, na srednjim druge, na visokim totalno različite za svih ostalih pojava koje postoje. Tako su razdvojili software recimo na 4 generalna nekakva solvera i 20 specifičnih solvera za specifične aplikacije. I na taj način su vrlo adekvatno i fino pokrili kompletni spektar i sve to skupa je zapravo bez ikakvih prekida i možete prebacivati iz jednog solvera rezultate u drugi solver i nastaviti analizu tih rezultata u drugom solveru. Recimo prelazite iz nekakvog EM solvera u termalni softver. Nikakav problem. Isti softver, isti interfejs, sve isto, ne morate se učiti ništa drugo, ništa drugačije. A pokriva doslovno od optike, elektromagnetizma, ovih čestica, apsolutno sve. Pa tako onda sa CST studijom, naravno, možete vrlo jednostavno napraviti vrlo komplicirane situacije i nekakve simulacije gdje zapravo, bez obzira na cijenu koja nije tako loš, mala, jako puno štedite na različitim komorama, nekakvim uslugama za nekakvo mjerenje i u principu sve što ste napravili, ako vidite da je nešto loše, vrlo jednostavno možete to promijeniti. Jedanput kad dođete do kraja, do komore, jedino možete dobiti rezultat ne valja, ili ako je netko dovoljno dobar i ima vremena vam objasniti, opet morate napraviti iz početka sve što ste radili. A sa CST-om jednostavno napravite malu promjenu u dizajnu, ponovo je simulirate i vidite da li su rezultati bolji ili lošiji. I na taj način zapravo radite veliku uštedu. A primjenjiv je apsolutno svim industrijskim granama. Od licenci, znači imamo mrežne nodlock, kupovina trajne licence, ili ako je to doista velika stavka u vašem budžetu, moguće čak i najam licence na kvartal ili godinu. Za edukacijske ustanove, škole, fakultete i tako dalje, naravno postoje akademske licence i naravno javite se obavezno, skoro uvijek možemo dobiti nekakve popuste na, što bi rekli, list price cijene. Tako, ja sam napravio ovaj kratki uvod. Drugi dio dijela će biti na engleski, pa ću ja samo onda kolegi Danili predati prezentaciju i predstavi ga. So, my dear colleague Danilo will continue. I have to make him as presenter and he will show you analysis for low power DDR4 memory. So I hope he will accept presentation, and here he is.
Yeah, I'm
okay.
Here.
Hi Danilo.
Let me choose. Thank you for your kind introduction. Let me choose the screen that I want to share. Yeah, do you see something?
Yes, now we can see your presentation.
Oh, great. Yeah, great. Thanks for your kind introduction. My name is Danilo Di Febo. I'm working for Dassault System, and I'm specialized in electromagnetic application, let me say. Today we will see one nice presentation, and the presentation will be divided basically into two different parts. The first one, I will give you a short introduction using a couple of slides just to fully understand what's the idea behind. Second one, we will see directly how our CST environment works, especially in signal, in this case, signal integrity applications, starting from the import, starting from scratch, basically. We will see, we will import just a simple board. It's just a demo board, basically, that we usually use to test and see and create all the material that you see on our website. Basically, we are talking about a microcontroller connected with more than one DDR4 in low power DDR4. We will import from scratch the full layout. We will set the IBIS file from memory side and also for the controller side. We will set everything where everything means signals that should be used for a read cycle, for the writing cycle, and for everything to describe the full channel and have an idea about the potential issue that we can see when we are talking about DDR4. We will set everything, including the I dimension, the minimal I dimension that we need to respect. And at the end, we will run the simulation, and CST create for you all the connection, all the signal, take care about the net, connect the IBIS file from one side to the other side automatically, and create more than one CST project that are intended to use for each single condition. Read condition, write condition, timing in write condition, timing in read condition. But let's see how we can do that. And in this case, let me switch directly to the CST interface, because it's better to see how does it works directly. Let's start from scratch. Basically, this is the simple CST interface. It's a bit empty. You have the full bar on the bottom side when you choose basically which kind of starting point you want to use. Directly import the ODB++ in our 3D environment, or starting from PCB Studio. This is the case. Keep in mind that it is possible to export directly from PCB Studio and convert geometry directly into the 3D application. Let me use this combination, this arrangement for the desktop, just because I want to show you how easy it is to import an ODB++ into CST environment. Let's start from the beginning. It's just drag and drop. Our ADIA interface will recognize exactly which kind of format we are trying to import. It is possible to choose what we want to import at the beginning. Basically, in this case, it's the first time that we are importing this model, and we are interested in importing everything, more or less: the layout, the stack up, the component, and also the component model associated to the this kind of board. But keep in mind that it is possible to import to re-import an ODB++, especially in case you have changed the geometry, into the old or the same or the previous version of CST file. In these cases, you can import directly only the changes. In case the layout is changed, import only the layout, or in case the stack up was changed, you are allowed to import only the stack up without changing nothing else. In this case, all the setting that you have done in the previous version, all the simulation that you have performed will be remain. The material will be updated when you will click import here, and everything will be updated in all the CST file generated starting from the main CST project. What we have also introduced into the ADIA import, it's the possibility to see exactly the stack up first, the material associated to the stack up, all the thickness, all the electrical properties, and it is possible also to change the thickness if you need it, of course. Let's click on next. The wizard suggests you to check all the net, suggesting to click the auto tagging button. In this case, CST recognize the type of the net place design over the board and classify this in 4 main different classes, let me say. Of course, ground and power, it's self-explained, and also differential net or single-ended net it's the default base, basically. But when we are talking about power, ground, or differential, CST try to recognize this kind of signal based on the name or combination of the name that found inside the net classes or the net name. In this case, all the net that terminate or contain something like _p or _n or h or l at the end of the name will be considered as a differential net. It is possible also to edit this kind of list, especially if the layout guy used other combination to other word or combination of letters to indicate differential net or single-ended or power or ground net. Let's click on start just to be sure that CST recognized all the net, because behind this recognition CST attached some specification into the signal, specification that will be used in our rule checker just to see if all the most common rule in terms of EMC guidelines are respect or not. I mean, net that across slot in power plane should be avoided in case our rule checker found this kind of violation. CST tell you where is this kind of violation and anticipate more or less some EMC issue. Sometimes we are forced to do that, and at the end of the story we will take care about all the trade-off that we accept to design this kind of layout. Let's click on next, because our main intention is to import some component that describe, for example, the active component that we have. In this case, we are using U1 as our DDR controller, and to do that we will click on edit component model, choose the IBIS file, in this case is an input-output devices, and assign the IBIS model connected to this input-output devices. Let's see, it's exactly this. We will open it directly. As you can see here, there's a lot of submodel inside, and all of these are automatically assigned by using the pin name associated to the pin connected to the chip in these cases. Let's do the same for U4. That is more or less our RAM, our DDR RAM, let me say. We'll use the same setting, input-output devices. We will click on assign IBIS model. Let's choose the IBIS model. In this case, it is this one. Let's click on open. Let's click on OK. In this case, we are using this IBIS modeling, but it's inside this IBIS package. There's more than one packaging for that describe the same memories. Let's click on OK. Automatically CST recognizes and assign all the net, all the models, and also let me say the model associated to the single pins. Let's click on apply and click next. Now we are at the end of our wizard, where generally speaking, when we are talking about CST, when we are talking about PCB imported into PCB Studio, it is possible to set directly IR drop simulation if we want to take care about the drop voltage over the board. This is crucial when we are talking about low power memories or low power component mounted on board. Same story when we are talking about the power integrity application. Let's see if the impedance seen from the sources, I mean the power plane impedance, are can be controlled, and most of the time we will place a lot of capacitance, decoupling capacitance, just to be sure that the emission coming from the power plane could be negligible in some cases, and also the noise propagated inside the board due to the simultaneous switching, and this, as you know, generate a sort of noise internal inside the board, between the pins, between the vias, just to be sure that this noise it's under control from one side and is not able to generate any fault or any unwanted condition. We suggest to run also this kind of simulation. At the end of the story, you have also the possibility to run some signal integrity simulation directly using our frequency domain application or directly in time domain. In these cases, we will skip this step. Let me arrange a bit more in a convenient way the model that we are using, and let's use our DDR4 button to start the simulation that we have. First of all, we should select the DDR controller. In this case, it's of course U1. The DDR memories is included and is well described using the IBIS file inside the U4 component. This is more or less what we need to do. Let's click on simulation setup just to be sure that everything is set in a proper way. We are talking about low power DDR memories. We need to choose exactly the right signal, and we need to choose also the right timing for this kind of pins. In these cases, we are using DDR technology at 3200 as a main bit rate. Of course, we will change everything. In this case, it automatically all the I mask read in this case is the same for the write, and for all the other will be changed. We need to adapt a bit the DDR I diagram, because in our cases we are using a low power DDR. Let's have a look at the properties that we are using for writing and reading process. This is used to generate all the all the I diagram at the end of the story. In this case, it's already set, of course. And let's have a look at the IBIS model used to describe and used to generate, as I will show you in a minute, all the connection between the DDR controller from one side and the memories on the other side. Let's start to select U1 controller. We will use our filtering process. Let me also arrange the signal in a common way, and we choose all the DQ signals. In these cases, we need to change the model associated to the read process. In these cases, we are using DQ input on determination as a 40 ohm. Let's click on apply. We will do the same for the DQS signals. We will select all directly, click on read model. Let's edit it, and we will use DQS input as on die terminal as a 40 ohm application. Okay, let's click on OK. In this case, it's automatically CST arrange all the IBIS model associated to each pins. What we need to change now is just from the visualization point of view, the correct dimension of the minimum aperture, let me say, of the I diagram. We will change directly, just selecting all the DDR, the DQ signals, let me say, because most of them are associated to the DQ signal. Just click on I diagram, select one, and choose directly low power DDR4 3200 bit as a bit rate. It's something here. Let's see, it's exactly this. Click on apply, click on close. Great. We should do the same or something similar for U4. Also in this case, let me arrange the signal as a DQS at the beginning. We will need to change the model associated to this kind of pins. The read one in this case, let's click on edit and choose exactly CA input diagram on the terminal is already it's already set. Let me choose on the read mode also the clock signal. It's this kind of two type. The read model associated to these two pins should be added into clock input on the termination as 40. It's correct. Same story for the CS signals. Read model, edit, and check if the buffer name is the CS input on the termination as 40. Let's do the same for the read in case of write mode, of course. In this cases, the write buffer associated to this should be changed. Instead of, we should check if we are using the input on the termination. In this case, it's correct. It's more or less a double check just to be sure that everything is set in a proper way. The DQ model associated should be DQ input model, not output. In this case, on the termination as a 40 ohm. Let's click on OK. Same story for CS, same story for the DQS signal. I forgot this one. Edit as input. Okay, same story for the DQS signal. We will choose the correct buffer model. In this case, it is DQS input on the termination as a 40 ohm. The clock was set as an input. The CS signal was set as an input. The DQS and DQ was set as an input, as you can see here. What is remain is just to set the I mask for the writing cycle. Same story, we will select all the DQ signal. Let's click on select. We will use low power DDR 3200 rectangle. Let me say it's already designed by CST. Let's click on apply and close it. More or less, we are ready to run the simulation. We want to see also some extra let me say some extra eye diagram related to the CA signal and CS signal. That's why we are selecting all of them. It is possible to select all directly. Just arrange in a different way the signal name. Click on I mask write, and let's choose the same for CA and CS. What I need to do is low power DDR CI and CS at 3200. Let's see this one. Okay, it's a different way. Great. Basically, we are ready to start all the simulation related to and generate all the eye diagram in read mode, in write mode, and also the timing that we want to use directly. Let me unselect the automatic labeling. Let's choose a name for this kind of project. Low power DDR memory demo. In these cases, we will use PCB Studio for that. Let me skip by default. Generally speaking, at this stage, we will always suggest to click to select Start Analysis and run everything. More or less, this takes 10 10 minutes to run all the modelings and generate all the signal. At this moment, I will show you how all these modeling are generated. I've simulated this for you already at the beginning, just I don't want to waste your time, basically. Let's click on start. Okay, it's just a warning. In background, CST is creating more than one PCB project, or CST files, if you like, where everything is set automatically. We will show you in a minute, where all the connections are done automatically. I mean, connection between memories and controllers. We will assign the correct controllers, the correct input and output buffer from one side and also to the other side. We select automatically all the modeling associated to the net, and also the net are selected automatically. That's why if we have a look at the main project, this is the main project, we will have more than one, in this case it's just two, more than one project, CST project, I mean, where inside, if you double click here, you see exactly a copy of the PCB that you are investigating. And into the schematic side, you can see all the connection inside. You can see all the connection, the same story for the other side. And generally speaking, what we are creating automatically is something like that. This is what I have already done a few minutes ago before to start this webinar. If we had a look at the schematic side, we can see the main PCB, all the net selected to run the simulation, all the IBIS file connected to the proper net from the memory side and also from the controller side in each kind of condition, in read condition, in write condition, in timing, performance channel, both sides, read and write. In these cases, we are exciting each port with the proper signal. In this case, it's just a square PRBS just to be precise. Each port are selected with the proper voltages, with the proper signal or voltage used to drive or switch it on or switch it off the IBIS file. In background at the end, in case of timing, we will have also all the eye diagram generated in automatic way in these cases for all the DQS and DQ signal that we are using. There's also a comparison between DQ and DQS signal if you want to have the opportunity to have an idea about which is the impact of the channel where all the signal are traveling. These are done automatically. We need just to create and set everything. I mean, IBIS file or run the auto tagging mode or check if the proper buffer model is attached or connected, if you like, at the right net. And by default, CST create for you all the connection, all the signal around the simulation background. More or less, this for simulation takes 10-15 minutes at least. On my laptop, of course, it's not the fastest laptop that I had in my life, but it works for me, of course. You can see here all the eye diagram generated by the tool in several different conditions. You see also all the signal that travel across the net with a lot of spikes in some cases, a lot of noise or distortion. It is possible to have a zoom to see exactly what's happening. This for all the signal put in place into this simulation. As you can see here, there's also modulated something. Probably there's an extra capacitance due to the geometry. It is possible also to monitor the common mode, because most of the time the common mode directly generates emission outside the board. This is the level of common mode for the DQS signal. Same story, the differential net used to excite the system. But basically all of these are done directly into PCB Studio. There's a way also to export, because at the end of the story, when you reach all the trade-off to design this board, you have simulated, optimized, and check everything. I mean, power integrity, signal integrity, IR drop, and all of the other check that you can able to run before going directly into the 3D. At a certain point of your life, you should investigate also the radiated emission coming out from the board. To do that, it's in CST more or less it's easy, because it is possible directly to export from PCB Studio directly into Marković Studio. It is possible also using the ADI interface that will appear in a moment to place all the port automatically. This is more or less the ADI interface. It is possible to place all the port automatically. For example, I want to investigate all the DQ signal from one side, and also from U1 side, I mean the controller for, and also from U4 side, I mean the memory side. It is possible also to select all of them, just add and tell to please CST connect, create all the port in this position, and please use as a reference net the ground that we have inside the board, just to be sure that everything is set correctly, because it is possible also to choose different type of ground, but in these cases we need to check if all the ground net and all the ground plane are connected together. In this case, the CST will create all the connection for you. If we click on finish import, CST collect all the information and more or less generate the 3D version of your PCB, where all the ports are already connected. Basically, you are ready to run the simulation. Just you need to check some small setting like the frequency range that you want to investigate, starting from 0 up to a couple of gigahertz, or hundred of gigahertz if we are using a very fastest rising time or falling time in our board, especially if we are talking about high speed, very high speed application. Let's set 5 gigahertz, just to give you an idea. In background, CST is just arrange something like the mesh. Some setting will be done in background. In this case, we are using the frequency domain solver, but it is possible also to use the time domain solver. Just check the background. In this case, it's a bit greater than the board. We have had 5 millimeter extra, 360 degree over the board. The properties of the normal material is more or less the same properties of the same electrical properties of vacuum. It is possible to check the boundaries. Typically in this case it's open, more or less we are simulating the PCB in a free space. That's it, it's able to radiate everywhere. And it is possible also to add some field monitor, just to check what the electrical or magnetic field distribution over the space. at a specific frequencies. It is possible also to insert more than one frequencies. This is what I've done for you just yesterday, just to be sure that everything works fine. Give me just a minute. I will show you some results. What I've done here is also I've added some extra monitor just to see what happened at using different frequencies. I mean, I'm plotting here just electrical field at several different frequencies. For each port, it is possible to have an idea about the electrical distribution over the board, or if you like, using the arrow. It's up to you. Basically, it's just a graphical visualization where that you prefer to see what happened on different planes, for example, or all over the space. Another thing that we can do is just to combine the electrical field monitor in case we are connecting something into the schematics. It is possible to connect extra component here, to connect port, to use different type of signal. I mean, what happens if a square waveform is traveling on the clock side, which kind of emission is able to generate. It is possible to place a port here. For example, it's just an example. I just picked up one of the pins. It is possible to terminate all the other port, for example, with termination resistance. In these cases, there's too many ports. We have a macro to do that. Add all termination resistance to all the port. It is possible also to use some parameters if you like, or add or not add probes. In this case, CST is just connecting the termination resistance for each unconnected port. At the end of the story, it is possible to create some task, AC task or transient task, and use the power of our solution to combine the results and generate all the voltage and current evaluated into the schematics and reflect this and combine all the electrical field monitor in a way that give you some useful information. For example, what's happened at the electrical field in case this specific configuration is used, where some square signal is injected into the system and all the other pins are terminated over a specific resistance. How to do that? It's easy. Just click on task, new task, transient task. In this case, CST generate for you a sub-project where the transient task is used. It is possible to choose the maximum simulation timing that we want to use. It is possible to choose also the excitation that we want to inject into the port. If we click on define excitation, we have some predefined signal. Usually in these cases, we are using PRBS or some pulse signal, but it is possible also to use Gaussian pulse, sinus, exponential signal, damped sine, or import directly something using your own signal, basically just an ASCII file where frequencies and amplitude, or frequency and voltages, or frequency and current, or frequency and power most of the time is used. It is possible to define which kind of source should be used. In these cases, I'm using just voltages. And another things that is useful to do is to enable the combined results. In these cases, it is possible also to select all the monitor that we want to combine. In this case, CST combine all the monitors in a way that give you the electrical and magnetic distribution at these frequencies where your own signal is injected into the system. Basically, where we are trying to reproduce the emission coming out from this configuration directly into our CST environment. Great. Basically, we are at the end of my talk. Let me go back to the slides just to see what we have done directly using the software. We have chosen and select the correct task IMASC diagram for each kind of condition, read condition, write condition, timing condition. It is possible to start directly the simulation at the end of the setting. Basically is what we usually do. CST create for you all the modeling, create all the connection. If we click on signal integrity time domain, it is possible also to check or consider extra data to simulate. And at the end of the story, when all the process was done, clicking on DDR refresh result, it is possible to see, to have an idea about all the graphical idea, I mean, and also have a nice table where it summarized all the settings, all the eye diagram, opening and width, and if it's complying, if the eye diagram calculated by CST, it's open enough compared with the minimum requirement coming from low power DDR4 standard, more or less. Basically, if we select one of each eye diagram where it is specified, of course, this is the main, probably the main information that you want to choose, it is possible to see exactly the correct eye diagram, the corresponding eye diagram with the aperture that we have set with the condition of writing condition or reading condition. It is possible to see the results directly for this kind of net, this kind of signal, and basically these are done directly for each signal that you have decided to investigate in this condition. That's all from my side. Thanks for your attention. In case of questions or doubt, please feel free to use the chat panel. Matthias or Renato will take care about the questions. We will try to answer directly if it's easy to answer. I mean, if the answer takes not too much time, otherwise we will send you an email, or please feel free to send us an email in case you have extra question or extra doubt. Thanks for your attention.
Okay, thank you Danilo for great presentation. Ok, hvala vama također na slušanju. Budemo malo pričekali ako ima kakvo pitanje. Ako ne možete se sad trenutno sjetiti što bi pitali, dapače imate naše mailove, šaljite u mailovima pitanja koje vas zanimaju i potrudit ćemo se odgovoriti vam. Ovo je sad mi pobjegao panel, samo malo, tehnički problemi. Ne mogu vidjeti pitanja, sad ih vidim. Dakle, pitanja nema. Velim, uvijek se možete javiti nama sa bilo kakvim pitanjima, slobodno. Kolega je to jako lijepo prezentirao, nadam se da vam je bilo više manje sve jasno. Ako nije, pitajte. Ne mora vam baš sve biti jasno, ko kaže. A za sve nejasnoće mi smo tu. Tak, eto, ne vjerujem da će biti nekih pitanja. Puno hvala još jednom na slušanju i gledanju. Nadam se da vam je bilo korisno i nadam se da ćemo se vidjeti opet. Eto, zahvaljujem u svoje ime svoje firme, kolege Danila i mog kolege Renata. Hvala lijepa i vidimo se opet. Doviđenja.